Good morning, everyone. So today we will discuss on the topic that is water in the atmosphere. Now we all know that Earth constitute about 70% of water, that is aqueous areas, and about 30% is the solid land mass areas. Now in the atmosphere also there is some amount of water in different forms. If we look at the total water content of Earth, then we will find areas in different forms, and majority of the water is restricted in the oceans, about 97%. In the fresh water, that is within the land areas, in lakes, 1.7% to 2%. Whereas in the polar regions or in the high altitude areas, in the form of ice caps or in the form of glaciers, in the form of snow, it is about 2%, and only a very minute fraction, that is about 0.001%, is stored as water vapor, mainly in the atmosphere. Now the effect of this minimum or very minute percentage of water vapor within the atmosphere, although it is present in a very small amount, but the effect is not so small. With slight change in the concentration or amount of water vapor in the atmosphere, it causes a change in temperature condition for a shorter time, and it can also change the climatic condition for a longer time also. So water vapor, what basically do, it acts as a trap for the both incoming solar radiation and the outgoing terrestrial radiation. Say for example, in today, right now, when we are going through this lecture, you can feel a relatively uh, colder climate, colder condition compared to the normal temperature what we found during the month of May in India. In India, it is the peak of summer season, so extreme hot condition about 40, 42 degrees centigrade, what we generally face in this time. But just for the past few days, we are evidencing about 30 degrees centigrade near about temperature condition. Now, what caused this change from the normal 40 to 42 degrees centigrade to the present day near about 30 degrees centigrade? It is the clouds. This cloud, which basically hosts the water vapor in the atmosphere, they basically discard the incoming solar radiation to reach the Earth's surface. So thereby, as the Earth's surface did not receive much of the incoming solar radiation, the average temperature for the day remains somehow or somewhat cooler compared to the other year's average temperature during this time. Similarly, during night time, if there is cloud cover, they trap the outgoing terrestrial radiation. So thereby, the effect of cooling during night time is not so vast, rather than a more or less um, definite or constant temperature condition exist throughout the entire day. During daytime, the cloud discards the insolation, thereby cools the Earth's surface, and during night time, the cloud traps the outgoing terrestrial radiation and thereby restrict the Earth's surface to cool in a much higher amount. So you can see that with slight change of this water vapor content in the atmosphere, how the weather conditions, and the most readily observed factor is the temperature, how the temperature condition of the atmosphere can change. Now, water, it is a unique thing. It can simultaneously exist in three states, that is in solid, liquid, and in gas. And the most interesting thing is that often the two forms or two different states of water can coexist at the same temperature. So you can see from this simple diagram that from water, it requires some amount of heat to be evaporated or to go into the gaseous condition. Then from gaseous condition, again, it has to cool down and condense to form water. If we cool down or condense water further below freezing point, then it forms solid, that is the ice. And from ice, by increasing temperature, it melts and forms liquid. So this process is general to us, and in this way, during conversion from water to water vapor or water to ice or vice versa, to change the state of water, it requires some latent heat. Now, latent heat is the amount of energy which promotes the change of state of water without changing the overall temperature. So, at 100 degrees centigrade, both water and water vapor can coexist, but the difference is that water vapor contains some extra amount of latent heat, about 580 degree, 580 the value is calorie, 580 calorie. Similarly, at 0 degree centigrade, both water and ice can coexist, but ice has lesser amount of energy, about 80 calorie. Uh, so in this way, in same temperature, the two forms like ice water or water water vapor can coexist, and they can mutually change from one form or one state to another state. Now, in another transformation process, water from its solid state can directly go to the gaseous state without going to the intermediate liquid state. So from solid, direct conversion to gas. This process is known as sublimation. The reverse process can also happen, that is from water vapor, the gaseous state, direct conversion to the solid state, that is ice, without going to the liquid state. Now, in some books or in some literatures, you may found that this reverse process, that is the direct conversion of water vapor to solid ice crystals, also some people called it as sublimation. But for scientific use, scientists prefer the term sublimation for the conversion of ice to gaseous state, that is water vapor, and the reverse process, that is the conversion of water vapor to ice, the process is known as deposition. Now, in nature, water is constantly changing its state through the atmosphere. From the hydrological cycle, we know that water evaporates from the Earth's surface by taking the incoming solar radiation. It becomes heated up and goes to the gaseous state, that is water vapor. It goes up. The water vapor is relatively light because the distributions of molecules in water vapor is less dense compared to the liquid state water. So because of the lesser density of water vapor, it goes up. When it goes aloft in the upper atmosphere, it condenses and gradually cools down due to adiabatic cooling and forms clouds. The clouds formation generally depends on the amount of dust particles present in the atmosphere, because those tiny water vapor, they need some nucleus to be concentrated and form the clouds. Now with sufficient further cooling, the clouds condenses more. The tiny water vapor droplets, they collide with each other, form some larger water drops, and with time, when the cloud is not able to hold them, they falls back to the earth's surface in the form of rain, or if further cooling occurs, then it falls on the earth's surface in the form of snow. Now this cycle, the change of state of water in various state, from liquid to gas to liquid or solid, then again to gas. This cyclical change of state of water is one of the important way by which the heat or the energy is transferred from the surface of the earth to the atmosphere. Because for water to evaporate, it requires some extra amount of energy, that is the latent heat. So the surface from which the evaporation occurs, from that water takes this extra energy, the latent heat. So the surface from which evaporation occurs, that basically cools down slightly. Similarly, when water vapor cools and condensed in the upper atmosphere and falls back in the form of rain or snow, so again a conversion of state occurs from gaseous state to liquid or either or solid. So again it has to release some amount of energy, that is the latent heat, and this latent heat is stored in the atmosphere. So what was previously in the surface of the earth, that will take as latent heat by the water vapor, and this latent heat is again released in the atmosphere when they are condensed and falls on the earth's surface as rain or snow. And that release of latent heat is about 23% of the solar flux incident on the earth. So thereby this circulation of energy from the surfacial condition to the atmosphere with the changing state of water is one of the driving source for circulation of energy from the surface to atmosphere. Water vapor is also the most important greenhouse gas in the atmosphere. The heat radiated, that is the terrestrial radiation, the long wave radiation, which is emitted from the Earth's surface, is basically absorbed by the molecules of water vapor in the lower atmosphere. The water vapor molecules in turn radiate this heat again into the Earth's surface, and thus water vapor is the second source of warmth in addition to sunlight at the Earth's surface. And particularly, this warming can be felt in the night time, because during night time there is no incoming solar radiation. So the source of energy coming from the sun, that will be discarded during night time due to the rotation of Earth around its own axis. So it has to be cooled down. The Earth seems to be cooled down during night time. But because of this water vapor in the atmosphere, the outgoing terrestrial radiation is trapped. So more or less, although Earth's surface is gradually cooling during nighttime, but more or less a uh, suitable temperature condition exists during nighttime. So that is why the variation in temperature during day and nighttime is relatively low. If there was no water vapor in the atmosphere, then there will be a huge variation in temperature during day and during night. Now, the water vapor in the atmosphere or in the air is expressed by a scientific term that is known as humidity. So it is simply basic an expression of the amount of water vapor in the atmosphere. The amount of water vapor present in the air is called humidity, or often it is called absolute humidity. But how much water vapor can a air can hold? There is a limit. The maximum limit of water vapor that air can hold for a particular temperature is called its saturated condition. That means at that particular temperature, the percentage or the amount of water vapor in that given amount of uh, air is 100%. Now, when air is saturated, the humidity will be 100%. That is, no more water vapor or moisture can be added to that particular volume of water. But this saturation, that is the amount of water vapor within the given atmosphere, can vary with temperature as well as the volume of atmosphere. With increasing temperature, the amount of holding water vapor will increase. Similarly, with increasing volume of air, the amount of holding water vapor will also increase. Now, in general, the air does not contain the maximum or the 100% water vapor in it. At this condition, the air is said to be unsaturated. So mostly the airs are unsaturated, that they does not contain 100% water vapor, that is the maximum limit, and that is why they can take further water vapor by evaporation from the surfacial condition or from the surface of any aquatic body. A saturated air will become unsaturated if you raise the temperature. Just what I called or what I told you in the previous slide, that with increasing temperature, the air or the atmosphere can hold more amount of water vapor. But when you are changing the temperature to find out the relation between the water vapor contained with temperature, you have to fix the volume. So basically the amount of water vapor in the atmosphere is proportional to the temperature and the volume of air. So one has to be remain constant to find out the relation with the amount of water vapor. Similarly, if you decrease the temperature alone of an unsaturated air, after some time it will become saturated. Now, apart from the saturated air or unsaturated air, in meteorology, that is the atmospheric science, there exists a condition in which the atmosphere is contain greater than 100% water vapor. That is, it contains more water vapor than it is needed to be saturated. This condition is known as supersaturation, and the air is known as supersaturated air. Now, there are several ways to measure the amount of water vapor within the given amount of or within a given volume of atmosphere. That is to measure humidity. We can express humidity in terms of vapor pressure, in terms of absolute humidity, in terms of specific humidity, in terms of mixing ratio, relative humidity, and dew point temperature. So these are the different expressions by which we can define the amount of humidity of any given atmosphere. So firstly, the vapor pressure. Now, vapor pressure is the pressure which is exerted by the water vapor within a given amount of atmosphere. So in a package or in a volume of atmosphere, there are some water vapor. Now this entire atmosphere has some pressure. Within that total atmospheric pressure, the part of the pressure which is produced by the water vapor, that is known as vapor pressure. The unit of vapor pressure by which it is expressed is generally Pascal or kilopascal or millibar. The rate at which a rising parcel of unsaturated air cools down with rising up due to uh, adiabatic cooling, that is known as dry adiabatic lapse rate. Similarly, the rate at which rising parcel of saturated air cools, that is known as saturated adiabatic lapse rate. So the same thing, that is cooling of air with increase in height. In the first type, there is the rising air is unsaturated, and in the second type, the rising air is already saturated with water vapor. And you can see the change in temperature. In case of unsaturated air, that is the dry adiabatic lapse rate, or it is often abbreviated as DALR, the rate is 1 degree centigrade per 100 meter. Whereas when the air is saturated, that is for saturated adiabatic lapse rate, or it is abbreviated as SALR, the rate is 0.5 degree centigrade per 100 meter. Now there exists another term which is known as saturation vapor pressure. So from the term you can get an idea that it is the vapor pressure of the atmosphere when the atmosphere is saturated with water vapor content. That means it reaches its peak, it reaches maximum limit, that is it is contain 100% of water vapor. At this saturated condition, the vapor pressure is known as saturation vapor pressure. Now, the saturation vapor pressure can also change with temperature, because with temperature, the saturated condition of the given amount of atmosphere, that will become unsaturated. So at that time, we cannot call it saturation vapor pressure, because the air with changing temperature change its condition from saturated to unsaturated. Now, when an unsaturated air with rising upward change its condition from unsaturated to saturated due to adiabatic cooling, the level at which saturation is achieved is known as lifting condensation level, or it is abbreviated as LCL. Next term by which we expressed humidity is the absolute humidity. Absolute humidity is the measure of water vapor content in the air regardless of the temperature. It is generally expressed in grams per meter cube. That is, absolute humidity is basically a ratio between the mass of water vapor present in the given atmosphere by the volume of air, irrespective of temperature. Now, the value of absolute humidity depends on the volume of air. So it is basically, absolute humidity is basically inversely proportional to the volume of air. So with increasing volume of air, the absolute humidity decrease. The reverse is, with decreasing volume of air, absolute humidity of the air increase. That means the air tends to be more saturated with decreasing volume. The next is specific humidity. It is a ratio between the mass of water vapor by the total mass of the air in which that water vapor remains. It depends on the atmospheric pressure. The third one is the mixing ratio. It is the ratio between the mass of water vapor in the air and the mass of dry air, that is after discarding the uh, mass of water vapor. So two parts, one is the within the entire atmosphere, its total mass, and this atmosphere contains different gases along with water vapor. So when mass of water vapor is divided by mass of the total air, we call it specific humidity. And when mass of water vapor is simply divided by the mass of dry air, that is discarding the water vapor mass, then the ratio is known as mixing ratio. Next, the relative humidity. Again, it is a ratio between the mass of water vapor divided by the mass of water vapor at saturated condition multiplied by 100. So it is expressed as percentage. So what it basically is that within a given volume of water at any given temperature, sorry, within a given volume of air or atmosphere at any given temperature, the mass of water vapor that atmosphere originally have with it and the mass of water vapor that particular atmosphere can hold when it is saturated. Their ratio, when it is expressed in percentage, it is called relative humidity. Now, relative humidity also varies with temperature because with changing temperature or with increasing temperature, the amount of vapor content varies. With increasing temperature, the saturated air becomes unsaturated. So at that condition, the ratio becomes changed. So relative humidity inversely varies with temperature. Relative humidity indicates how near the air is in the saturated condition rather than depicting the actual quantity of water vapor content. So if we want to know the actual quantity, how much amount of water vapor a given amount of air or given amount of atmosphere holds, that is expressed by absolute humidity. But if we want to know that that particular volume of air is how much close to its saturated condition, then we expressed it in terms of relative humidity. The next expression of humidity is by dew point. Dew point is the temperature to which air must be cooled to become saturated with water vapor. The rate at which dew point decreases with height is about 0.2 degrees centigrade per 100 meter. Now, from an unsaturated air to become saturated, there are three ways to achieve this saturated condition. That is adding more water vapor. So unsaturated air means it contains less than 100% water vapor. So if you add more water vapor within it, then the value of water vapor content within it will increase. So addition of water vapor within that particular given volume of air in same temperature increases its saturation level. The second is the lowering of the temperature. to the dew point. So with lowering of the temperature, the saturation level can also increase, and this lowering, that is change in temperature, can occur in two ways. The first one is the diabatic process, in which energy is removed or added, and the second process is the adiabatic process, in which energy is not added or removed. The energy is remain constant, the total energy remain constant, but it occurs simply due to change in volume. So in the first case, diabetics, direct change in energy. In the second case, energy is constant, but volume change, due to volume change, change in temperature within the given volume of air found to occur, and thereby the atmosphere reach the saturated condition. And third way by which an unsaturated air becomes saturated, that is by mixing with a cold dense air. So when the mixing of cold air with warm air uh, happens, the warm air becomes cool, becomes more moist, that is becomes saturated. Now, how we measure measurement of the amount of water vapor within a given atmosphere, the device by which it is done is known as hygrometer. It's basically a funnel shaped instruments which consist two identical thermometer mounted side by side. You can see this one is one thermometer and this one is another thermometer. Now the amount of cooling that takes place in the hygrometer is directly proportional to the dryness of the air. And this psychrometer is basically a type of hygrometer. There are different types, among which the psychrometer is one of them. And to measure the humidity from this instrument, it requires a complex calculation with the help of these two uh, thermometers. In this class, we did not go into that detail, but you have to know that the device by which the relative humidity or humidity is measured is known as hygrometer. Psychrometer is a type of hygrometer. Now, humid air is less dense than dry air because a molecule of water is less massive compared to the other molecules found in the atmosphere, like the oxygen or nitrogen, which are the two most abundant gas found in the atmosphere. Together, oxygen and nitrogen, they comprises 99% of the atmospheric gases, and the remaining 1% of the atmospheric gases are basically a mixture of all other gases. And within this 1%, the water vapor content is about 0.001%. Now, for any gas at a given temperature and pressure condition, the number of molecules present in a particular volume is constant. That is a statement of ideal gas law. So when water molecules or any other molecules are introduced into the volume of dry air without removal of an equal number of other gas molecules, that necessarily require a change in temperature, pressure, or total volume. That is, it requires at least change of one of these three parameters. So either change in temperature, either change in pressure, or change in volume. Because with the given atmospheric gas, with the given atmospheric gas molecules, we are adding some extra gas molecules in the form of water vapor. So thereby it enhances change in temperature or pressure or volume or a combination of these two, between any these of these two or all of them. So if temperature and pressure remain constant, the volume increases. That is, the number of air molecules per unit volume of air must decrease. Now in nature, as we already came to know, water present in three states, that is the solid, liquid and gas. That is ice, water, liquid water and water vapor. And they can change their state from one form to other, from liquid to solid, from liquid to gas, from gas to liquid, from solid to liquid. Also, the change can directly happen from solid to gas or from gas to solid without going through the liquid state. Now, this change from one state to another state, either in this change of state to occur, either they require some extra energy, either they absorbs heat or they release some heat during this changing state. So when the change of state occurs from solid to liquid, in this changing state of water, the energy is transferred in the form of heat energy. That is, the solid ice, it requires some extra energy to move in the liquid state at the same temperature condition. So at 0 degree centigrade, the solid ice takes the amount of energy, and that energy is known as latent heat, by which the solid ice transferred to liquid water in the same 0 degree centigrade. So latent heat plays a crucial role in the atmospheric processes, and it is the major source of energy for many of the atmospheric disturbances like thunderstorms or tornadoes or hurricanes. So although overall the temperature remain constant during the conversion of ice to liquid at 0 degree centigrade, but there involves certain amount of energy in the form of latent heat. The next is the change of state from solid to gas. So we all came to know already that this conversion occurs without going through the liquid state, and the conversion directly from solid to gas is known as sublimation. Now, this is the process due to which often we found some smokes whenever the ice is removed from the freezer. We found these kinds of smokes around the ice. That is, here the temperature increase is so sudden that the ice crystal does not get the time to convert into the liquid state and then into the gaseous state. So without going to the liquid state, direct conversion of the solid ice to the gaseous water vapor happens. Deposition is the reverse process, that is when the conversion of water vapor occurs directly to solid. This happens when water vapor is deposited as frost on cold objects. Water's change of state from liquid to gas, or the reverse, that is gas to liquid. Again, in this process, the conversion from liquid to gas, again it requires some extra energy at 100 degrees centigrade to convert the liquid water to the gaseous water vapor, and this process is known as evaporation, and the energy required for this transformation is known as latent heat of evaporation. Now, evaporation is basically a cooling process. By cooling process, what I mean to say that during evaporation, the water requires the latent heat to convert it in the gaseous state, and this latent heat is supplied from the material or from the surface in which the water is previously raised. So from the superficial condition in which the water raised, from that the water takes the latent heat, so releasing of energy from the surface, and that energy is now trapped in the water vapor. So the with time, with continued evaporation, the surface from which evaporation occurs, that becomes gradually cooler. The opposite process, that is the conversion of water vapor to liquid, is known as condensation. Now, again, in condensation, to convert water vapor into the liquid water, it has to release the energy, that is the latent heat. So that energy is then released in the atmosphere. So the atmospheric temperature during condensation increases. Here you can see often we found these kinds of phenomena whenever we uh, take some hot water in a pot or in a glass. We can see that evaporation happened, and for taking evaporation to take place from the hot liquid water, it takes the energy from the pot or from the glass. So gradually the surface of the glass or the surface of the pot cools down. Now, due to this cooler nature of the pot or glass, when the hot water vapor after evaporation, they came into contact into the surface of the glass or into the surface of the pot, they cool down, and from water vapor it is converted to tiny drops of water which are found at the side of the glass or at the side of pot. So here you can see at the same time both evaporation and condensation to take place, and this is almost evidenced by us in our daily life every day, every uh, now and then. Now coming to the details of the processes. The first process, that is the evaporation. So as I already told you, it is the process by which liquid water is transferred to gas, that is gaseous state. Now what are the factors which affect evaporation? The first and foremost factor is temperature. More the temperature, more will be the water vapor in the atmosphere, and depending on the availability of heat at the surface, amount of water vapor generally decreases through increasing latitude, because we all know that the insolation energy falling on the earth's surface is maximum at the equatorial region, and as we move toward higher latitudes towards pole, the insolation gradually decreases. So the energy received at the surface is maximum at equator and minimum at poles, that is gradually decreasing towards higher latitude. So the availability of energy from the earth's surface is also gradually decreasing through higher latitudes. So the transformation of water vapor from the liquid water is also generally found to be decreasing towards higher latitudes. The second factor by which evaporation depends is the dryness of the air, that is how much unsaturated the air is. Dry air has a large capacity, that means it is more unsaturated. The air, it can absorb more and more water vapor, whereas close to the saturation of an air, that is more moist or dry air, it can take or it can absorb lesser amount of water vapor. Size of the water body from which evaporation can take place. Greater the size of the water body, greater is the evaporation to occur. Movement of air, greater movement of air enhances evaporation, because after the evaporation, that uh, vapor, if it stays in that position, then with time that air becomes saturated. So the process of evaporation after some time will be stopped. Now if we move this saturated air to some other place, then that area is now taken by the unsaturated relatively dry air. So with this circulation of air, the saturated or the moist air is replaced by the dry unsaturated air. So basically the circulation or movement of air enhances evaporation. Next is the cloud cover. Clouds obstruct the solar radiation as they absorb and scatter the incoming solar radiation. So clear sky is required for the evaporation process. If clouds absorb or scatter the radiation, then the percentage of percentage of insolation reach the Earth's surface decreases. So it requires a clear sky to reach the insolation completely to the Earth's surface, so that the surface of the Earth becomes heated up, and from that evaporation can take place. The opposite process of evaporation, that is the process by which conversion of water vapor occurs to the liquid water state, is known as condensation. The temperature at which saturation occurs, that is relative humidity, is 100% and water vapor began to change is called the dew point. Now condensation depends on the following factors. It depends on the relative humidity. If relative humidity is higher, that is the atmosphere contains more water vapor, more moist air, then the condensation will be also high. Secondly, greater the amount of cooling of air, greater the condensation. So with cooling, the volume of air gradually decreases. That is the obviously third point. The volume of uh, atmosphere or volume of air decreases, and with this decreasing volume, the given atmosphere become saturated with the given amount of water vapor content what it has. So greater the volume of water vapor, greater the condensation and greater the formation of clouds. Now the forms of condensation. In the nature we found different forms of condensation. The first and foremost forms of condensation is known as clouds. Clouds are the water droplets or the ice crystals that are found in the Earth's troposphere. Clouds formed when the relative humidity reaches 100% and as air rises up, it cools down, and this cooler air cannot hold much water vapor within it. So now that water vapor reaches the dew point, the water vapor starts condensing and the water vapor nucleated around some dust particles found in the upper troposphere, and this way the clouds are formed. Now in nature we found basically three types of cloud. The first type is known as cirrus clouds, which are which looks short, thin, like curly hair. They are detached from one another and they are generally found in higher levels, in higher altitudes. The cirrus clouds indicate a change in weather condition. The second type is known as cumulus, which means heap or pile. These are the fluffy cotton-like clouds, a huge heap of cotton or huge pile of cotton looks like. They are the rounded individuals of cloud masses having the flat base. It signals good weather condition. However, when the cumulus clouds goes higher, then they can cause bad weather conditions. The third type is the stratus clouds. These are flat, layered clouds. They are found mostly in the low levels of the atmosphere, low levels of the troposphere. They are occurred as sheets or layers, and they have covered a larger area of the sky. Usually, they did not bring rainfall with it, but sometimes rainfall can happen with the stratus clouds. So these are the three main types of clouds found in the nature. But most clouds, what we found in our daily life, they are basically a mixture of these three types. Here you can see at different level. So often, if we are classifying clouds, then depending on the nature or depending on the morphology of clouds, clouds are divided into three types: cirrus, cumulus, and stratus. Often a fourth type is also proposed, that is the nimbus clouds. These are dark um, clouds like the cumulus, but dark in color, contains lot of water vapor, and creates uh, heavy rainfall or thunderstorms. But in nature, depending on altitude, depending on level, we basically divide the clouds into three levels: the lower level clouds, that is the stratus or nimbostratus clouds; the middle level, the cumulus clouds; and the upper level, the cirrus clouds. But as I already told, that in nature the clouds what we generally found, they are basically the combination or mixtures of these three types of clouds: cirrus, cumulus, and stratus. And due to this, some prefixes are added. Zero, which means wisp of hair and found in the higher level clouds. Alto, that means high, mainly for the middle to higher level clouds. Nimbo or nimbus, that means rain. It is used to indicate those clouds which make heavy precipitation, heavy rainfall. Cumulo, it means heap, like the pile of cotton. And the last one, that is strato, means layered. So the combination of the three types of clouds with these prefixes, some of the examples are given here. You can see cumulonimbus. So with the nimbus clouds, the cumulo prefix is added. Nimbus means highly dark, precipitated, precipitation occurs from the cloud, and it is also occurs in heap, like a pile of cotton. So these two are basically clubbed in a single type of cloud. Similarly, cirrostratus, that is the layered low level clouds having some hairy texture. Cirrocumulus, again a hairy like, uh, but at the same time cumulus, some kinds of um, pile of cotton or heap is also found. Altostratus, these are mid-level layered clouds, stratocumulus, and nimbostratus. So these are the basically combination of the three types of clouds: cirrus, cumulus, and stratus. And clouds are generally classified according to the different altitude in which they are found. The low level clouds, that is the stratus, nimbostratus clouds; the mid level clouds, that is the cumulus, stratocumulus, altostratus, cumulonimbus; and the upper level clouds, that is the cirrocumulus, cirrostratus. Second type of, or the second forms of condensation take place in nature, that is dew. Now, Earth's surface, after receiving insolation, is heated during daytime, and during night time, when there is no supply of incoming solar radiation, the surface of Earth becomes cooler. Now sometimes the cooling becomes so high during night time that temperature of air close to the Earth's surface falls below dew point. And as the temperature of the air close to the surface falls below dew point, so condensation occurs, and At this time, water vapor is converted to tiny water droplets, what we often found in the leaves. These tiny water droplets, these are basically dew, and this is mostly found during winter time when the cooling of Earth's surface happened more. Condition favorable for the formation of dew, long nights, that is generally evidence during the winter seasons. Long nights help in providing more time for cooling the earth surface and air in contact with it. Warmer days, more warmer the day, more water vapor is added to the air, and during night time, due to the superficial cooling, more condensation will occur because the air is very much saturated with water vapor. So with little amount of decrease in temperature during night time, condensation happens. Calm air, that is no circulation or no movement of air. If air is calm, it will remain in contact with the surface of the earth for a longer period of time, and thereby condensation can easily occur and dew are found to form. More relative humidity, that is more amount of water vapor in the air, enhances more dew formation. Third type of condensation is known as frost. When the temperature of air falls suddenly below dew points, below the dew point is basically falls below freezing point, then water vapor is condensed in the form of minute ice crystals. These are called frost. The conditions favorable for the formation of frost, again long nights, more long the night, more cool will be there, more the formation of frost. Warmer days, more warmer the day, more water vapor is added to the air through evaporation. Calm air, if air is calm, there is no movement found, then the air remain in contact with the surface for a longer period of time, and more dew and ultimately more frost formation is found to occur. Frost happened when the dew point is below freezing point. More relative humidity, more water vapor in the air enhances more uh, frost formation. Clear sky, clear sky helps in radiating out the terrestrial radiation during night time, so thereby the earth's surface becomes more and more cooler during night time, so formation of frost will be enhanced. The fourth type is the fog and mist. When the temperature of the air mass containing a lot of air water vapor falls all of a sudden, then condensation of water vapor takes place, and the cloud of water vapor found to be present near the surface, then it is called fog. So fog is basically simply a surface cloud. Here the water vapor condensation occurs or the cloud formation occurs close to the surface. Generally formation of cloud found to occur in the higher part or higher level of the troposphere. But in this case, due to the sudden drop of temperature at the superficial condition, the water vapor condensation occur to very close to the surface, and clouds are found to occur near surface, and with evidence these kinds of fog. This is a very common phenomenon in our uh, places during winter times. In contrast to fog, mist is another type of fog, but this type of fog is generally found in the mountainous areas, mainly in the mountains. And the main difference of mist to fog is the occurrence of this type of fog. Fog is generally found in the flatland areas. Mist is generally found in the mountainous areas, and mist has relatively thick layer of moisture. So the moisture content in mist is relatively high compared to fog. With further condensation of water vapor, the tiny water droplets, that is the dews formed, they collide with each other and form larger size liquid water, or sometimes if the dew point goes below the freezing point, then directly from the water vapor snow forms, that is solid uh, water state forms, and that cannot be hold for a longer time in the atmosphere by the clouds, so they falls down on the earth's surface in various forms like rainfall, sleet, graupel, snowfall, and hailstones. Now, one interesting observation found if we look at the distribution of evaporation and precipitation at different latitude conditions. Now, we all know that the evaporation, which is depending on the incoming solar radiation mainly, that is mainly varying from Tropic of Cancer to Tropic of Capricorn, depending on the inclination of Earth axis at different position in its orbital path. So the portion of the Earth in which evaporation is mostly occur, that is restricted mostly to the Tropic of Cancer to Tropic of Capricorn. And with further increase in latitude due to the lesser amount of receiving of insolation, the evaporation gradually decreases. But in contrast to this pattern of evaporation, precipitation curves shows a somewhat different pattern, and along with the availability of water vapor in the atmosphere due to evaporation, precipitation is also guided by the global wind circulation. We all know that in the equatorial region, a low pressure zone exists, and due to that, the water vapor rich atmosphere goes up. And when it goes up, due to adiabatic cooling, condensation occurs. So, lot of rainfalls found around 5 degree to 10 degree north and south latitudinal conditions. But with time, these clouds, when move towards Tropic of Cancer and Tropic of Capricorn, the amount of water vapor in this cloud gradually decreases as it moves towards Tropic of Cancer and Tropic of Capricorn. So, as the amount of water vapor in this cloud gradually decreases, the precipitation amount also decreases. Again, this uh, wind found to goes down to the Earth's surface near about the high pressure zone found to occur in the 30-degree latitude of both hemisphere, and again at 60-degree latitude in both hemisphere. Another uprising of air found to occur due to the convergence of this warm dry air from coming from the subtropical regions in both hemisphere with the surfacial cold air coming from the polar regions. Due to this convergence in the surfacial condition, uprising again found to occur in the 60-degree latitudes in both hemispheres. So again, with this uprising air, whatever amount of water vapor it contains, it will gradually cools down, condensation occurs, and precipitation take place. So that is why we are found higher values of precipitation in the equatorial regions, whereas in the 30-degree latitude in both hemispheres, although the evaporation is high, precipitation is relatively lower, and at about 60-degree latitude in both hemispheres, although the evaporation is low, but precipitation is relatively higher. This is the global balance of evaporation and precipitation, which varies across latitude in both hemispheres. Now coming to the forms of precipitation. First and foremost forms of precipitation, what we generally observe is the rainfall. Warm air with water vapor carries these clouds to a certain height, where water vapor combines with the dust particles, forms cloud. By adiabatic cooling, the air or the cloud becomes cold, and when cloud is not able to hold the condensed water vapors, they fall on the surface in the form of water drops, which we called as rain. When the condensation of water vapors in the upper level of the troposphere occurs below freezing point, then water vapor turns into solid state without passing into the liquid state. So this is the uh, conversion of water vapor directly to solid ice crystals occurs higher up in the atmospheres, and due to this conversion, fine ice crystals, small ice crystals, fluffy, they formed. They grow while they are suspended in the atmosphere. Eventually, with increase in weight, with further uh, collision of these ice crystals with each other, they increase their mass, and with time they fall on the surface as snowfall. Now, this cooling or this condensation to occur below freezing point, it generally found to occur mainly in the polar regions and in the high altitude mountainous areas. So both are basically same process, happens by condensation of water vapor in one first case to liquid water, what we found in the flatland areas, in the mid latitude areas. And in the second case, here the condensation of water vapor occurs directly to solid without going through the liquid state, and it is occurs when the temperature of condensation is below freezing point, and mostly found in the polar regions or in the high mountainous altitudes. Next type of precipitation is known as sleets. When raindrops leave a relatively warm air and found a cold air near the surface conditions, because during condensation from water vapor to liquid water, the latent heat is released in the atmosphere. So the upper part of the atmosphere becomes warm. In contrast, the air close to the surface is relatively cold. So a temperature inversion often found to occur. Now, due to the contact of cold air near the surface, when rainfall occurs, suddenly coming close to the Earth's surface, the raindrops solidifies to some minute tiny ice pellets. These are bigger than raindrops, as during this crystallization increase in size occurs, because whenever uh, crystallization from water to ice happens, a volume increase is found to occur. So that is why these ice pellets are slightly larger in size than the raindrops. So it is basically the frozen raindrops happened just when they reach the air which is in close contact with the surface. It is not the uh, raindrops which hit the earth's surface and then after it solidifies. It is not the process. But during pouring, during coming down the raindrops, when it reach close to the earth's surface, the air close to the earth's surface is cooler, that is below freezing point sometimes. And during this time in the atmosphere, the raindrops suddenly chilled to ice pellets. So minute, tiny ice pellets are found to be precipitated, which are about 5 millimeter in diameter or even lesser in size. These are known as slits. Next is graupel. These are soft, small pellets formed when supercooled water droplets freeze onto a snow crystal, a process called reaming. The snowflakes formed in this way is slightly larger in size, that is 2 to 5 millimeter in diameter. Third type is the hailstones. When precipitation occurs in the form of hard, rounded pellets, is known as hail. Most hailstones measure between 5 millimeter to 15 centimeter in diameter. Now, from sleet to graupel to hailstone, you can see that there is an increase in size from 5 millimeter in sleet to 2 to 5 millimeter in graupel, and hailstones are above 5 millimeter. Now, sleets is basically happen close to the earth's surface. In contrast, all graupel is almost similar in size to sleets, but these are fluffy. So these are forms higher in the atmosphere. So the freezing occurs far ago before reaching close to the Earth's surface. And hailstones occur much higher in the atmosphere near the clouds at this time due to sudden chilling, due to sudden cooling, the ice crystals forms, and with time they increase their size and ultimately came into the earth's surface as hailstones having 5 millimeter to often 15 centimeter in diameter. Thank you.